Wait, Miss Baskin,
Yes.
could I leave at 11:30? I have another class.
Yeah, because I know that there is another class at 11:30. I should, for the most part, be done by then. So, yeah. And then, of course, the video is up, so you'll be able to watch that later. So for today, we are going back through covalent bonding, and we're going to go over how to do covalent Lewis structures. And I'm going to go over what it is you need to do for me for the week. And as a reminder, this is our only class this week. So that was as other classes have ramped up, agreeing to that they want to start meeting. It made the most sense for me to back down the number of times we meet so that you are not overloaded. So we will now only have class on Wednesdays. That gets recorded, and if you can't make this class because of conflict, you just have to communicate with me that that's the case and watch the video and chat with me as needed. So moving on. So as a review, this should all be review. How can you tell by looking at a compound if it is a covalent compound? What kind of elements are there?
If they're both nonmetals.
If they are both nonmetals. Okay, so we know we have a covalent compound if we have both nonmetals. So then the question is, so on my periodic table, where are the nonmetals?
On the right.
On the right. So specifically on the right side of the stair-step line, but do not forget about annoying little hydrogen. So annoying hydrogen is all the way over there on the left by itself, but it is still a nonmetal. So if you've got, there's really not that many nonmetals. There's really only about 16 that were ever going to be considered as nonmetals because we don't include the noble gases. And then of those, we often kind of just use the same ones over and over again. So you'll see hydrogen and carbon and oxygen and nitrogen and sulfur and chlorine and fluorine, like over and over and over again. Okay, so in a covalent bond, what are the electrons doing?
They're being shared, right?
They're being shared. Okay, so we are sharing. And the goal of sharing is so that everybody gets a full octet, right? That's the phrase here. A full 8 electrons, with the exception of hydrogen, because hydrogen's itty bitty, and hydrogen only wants a duet. So if octet means 8, duet is how many does hydrogen want?
2.
Only 2, right? Okay, so when we are doing Lewis structures for covalent compounds, it is slightly different than what we did last week with the ionic compounds. So the first thing to remember is we are not transferring anything. So that means nothing you draw this week should have an arrow in it. No arrows whatsoever because we're not transferring. Everybody gets to keep what they came with. So the difference here is I will tell you how many of each nonmetal element you're working with to try and make a compound, because they can come together in lots and lots of different ways. You have to remember that in a covalent sort of structure, carbon and oxygen can come together 2 different ways. You can get 1 carbon and 1 oxygen and make carbon monoxide, but you can have 1 carbon and 2 oxygens and make carbon dioxide. So I have to tell you that because right now you don't know how to do that on your own. So it's a little bit easier because I am telling you the puzzle pieces you're working with. Okay, so I just saw Naya, Rain, and Kamal. Got you guys. Okay. So I'm literally want you to imagine each of these nonmetals with their dots as a puzzle piece. And if you've got 2 dots, that is a full side. But if you've got an empty side or you've got a single dot, that is a puzzle piece that you can try and connect together. And I've actually figured out a way to do it on my iPad where we can literally, I'm literally going to spin these things around to fit them together so we can see how they are going to fit together. So the goal is to give everybody 8. to have 2 dots on every single side, whether they're their own dots or they're shared dots from somebody else. We want dots on all the sides. And when we share dots, we tend to draw it as a line, which you might have seen before. And when we have dots that are not shared, we call them lone pairs. And everybody gets to claim their lone pairs as their own. It's only the shared ones that get counts for everybody. Okay. So, oops, that is the wrong picture. My bad. So I'm going to do C1, C2, and C3 in your packet if you have them. I'm switching over to my iPad. So even if you don't have it, if you just have a piece of paper, you can do what we're about to do just fine. Come on. There we are. Okay. So you can see I'm telling you which elements you're working with and how many of them you have. So I'm saying you are bonding a hydrogen with a hydrogen. So a hydrogen with another hydrogen. So each hydrogen has how many valence electrons or dots?
One.
Has
One, yes. All right. So each one's got 1. And for hydrogen, how many are they looking to have by sharing?
2.
8. Or no, 2, sorry.
2.
Only 2, yes. So hydrogen,
Why they only go to 2?
because he's so
Leave it
little,
like that.
he's too little for a full 8. He can only handle 2.
But don't they still want 8, right? But they can only go to 2.
You have to think, if the whole goal is to become like a noble gas, and the noble gases have 8, there's one noble gas that doesn't have 8, and that's helium. So hydrogen is trying to be like helium and only have 2. So that's what it is. All right, wants 2, I'll put down here, like helium. Okay, so I need to fit together those 2 hydrogens in a way that has them share those electrons. So what I'm going to do here is, oops, I've got this hydrogen and I've got this hydrogen, right? So I want those to actually share electrons. So when I say that you can imagine these like puzzle pieces, like literally if I flip this guy over and put them together like that.
What?
Right? So this now is what we call the shared electrons.
It's a little crooked.
Thanks, Juan. So those are my shared electrons. And when I share electrons, I actually draw it as a line. So I would write this as a dash that connects them. So that is also my shared electrons. And you can imagine that a line, right, equals 2 shared electrons. So here you can see if I cover up the blue hydrogen, the red hydrogen has a line representing 2 shared electrons. So it will have its 2. If I cover up the red hydrogen, the blue hydrogen has that line representing 2 electrons, so it has 2. So everybody is happy here in this situation. So that's as basic as it gets. And we can make it a little bit more complicated. So the next one would be 2 hydrogens plus an oxygen. So again, I'm telling you that you've got this many of this element, and I'm assuming that I only have 1 oxygen. Yes, of course it's water. Yeah. So again, my 2 hydrogens, and each hydrogen has how many dots?
1.
Okay. And oxygen has how many dots?
8.
6.
6.
6.
Six.
Oh, wow.
It's got 8 total, but it's only got 6
Good job, Lily.
electrons.
Thank you.
Yep. Okay, so 1, 2, 3, 4, 5, 6. So if you look at the oxygen, can you see that it's got 2 sides that are incomplete? So this guy's got space right here, and it's got space right here. In those 2 spots, it can fit in and share more electrons. So, stupid. Why don't? Oh, because I'm in the wrong thing. That's why. Damn it. There we go. Technology is great. Okay. So there's my pieces. So I've got my oxygen, and I've got a space over here on the left right there. So I can hook those 2 together that way. And if I turn my hydrogen here, I can hook it up that way. So what you should see is that this would give me a line here, all right? So that's now shared electrons. And this is now shared electrons, all right? So this is representing 2 electrons here, and this is representing 2 electrons here. So if I cover up the H's, can you count 8 dots around the oxygen?
Yes.
Yeah.
Yes.
But Ms. Baskin, I have a question. Is that
All
how
of
you do
those
the-
get to count for O.
Is that how you do the diagram? Like you could put the H anywhere?
Yep.
Okay.
Yeah, that's why it's easier to do it. It's actually easier literally to do it with things that you can flip around. So that outline in red represents the 8 shared electrons, the octet that is around the oxygen. And then these 2 represent the shared electrons for that hydrogen. And these 2 represent the shared electrons for that hydrogen. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This hydrogen has 1, 2, and this hydrogen has 1, 2. So everybody is happy. Now, it doesn't matter exactly how you draw that. So you will normally see people writing it as ... H, like you normally see that. But if you're used to actually thinking of water as that quote unquote Mickey Mouse structure, this is a lot closer to that Mickey Mouse structure where you can see where it's off at angles. Like that's why it's off at angles. So that's water. Want to do another one? Okay.
Oh, look at an email.
I get emails all the time. All right. Chlorine and chlorine. Okay. So I've got 2 chlorines together. So each chlorine has how many? 7. 1, 2, 3, 4, 5, 6, 7. So that chlorine's got 7. This chlorine's got 7. But they each want how many?
1.
Well, they want a total of.
They want 8.
All right. So they want a full octet. So they each have a space to kind of make 1 bond, right? That's their available space. So what we're going to have, yeah?
Huh?
I don't know. So what we're going to have to do is, come back here. Stupid.
Whose mic is that?
There we go. Okay. So what we're going to have to do to get these guys to work is to imagine, right, that they're going to flip together that way. And now that's now my bond, right, with a pair of electrons in there that are shared. And if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8. So there's the 8 electrons for the chlorine on the left, And then I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for the chlorine on the right. And the ones that are in that overlap, that's my shared electrons. Does all of that make sense?
Yeah.
Okay.
Yeah.
So, I have a free space. So, I have just a whole lot of them. We're going to be able to put some together. So, let's see here. So, if I wanted to put this carbon together with some hydrogens, how many hydrogens or how many spots does carbon have to be able to bond if I look at this guy right here?
4.
4, right? It can put another electron at the top, the left, the right, and the bottom. So I can imagine that I could fit hydrogens literally on all sides. A hydrogen there. A hydrogen there. And flip this last one. Get bigger. Yeah. All right, and hydrogen there. So here, same thing. I would have
Jump him.
what?
They're about to jump him. Look at him. They're surrounding him.
So everybody's got 1, 2. All right, again, each line is those 2 dots. So my carbon gets to count all 8 of those. And then each hydrogen has its 2, its 2, its 2, its 2, and everybody's happy. So that's the formula for CH4, and that's actually the formula for methane. So if you have a gas stove, that is the molecule that's coming out of the stove.
Ain't that crack?
Okay, so if I look at this nitrogen, how many available spots does that nitrogen have to
I
make
can't
bonds?
see it. I can't see it.
Oh,
Can you pull it to
Is
this?
it
5?
It has 3.
It's got 3 available spots, right? Because it's got a pair
Good job,
on the
Lily.
right. So the pair on the right, you can't separate, like it's good, but it's got an available spot on the top, available spot on the left, and available spot on the bottom. So if I want to stick these fluorines on here, the fluorine can only make how many bonds?
1.
It can only make 1 because it's only got that 1 available spot. So I need to flip these
3
guys around,
fluorines.
right? So I need to flip these guys around a little.
So Ms. Baskin, when we're putting them together, we're just drawing the line instead of the dot, right?
Correct.
Okay.
Okay. So again, that line is, so I've got 3 bonds there. All right. So representing 2, 2, 2. So my nitrogen gets to count all of those. So it's got 1, 2, 3, 4, 5, 6, 7, 8. And each fluorine gets 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That guy is written as NF3, right? So 1 nitrogen and 3 fluorines. So it's this last one here with the oxygens that's a little on the tricky side. So if I look at these 2 oxygens, how many spots does each oxygen have to be able to make a bond?
2.
2. But if I'm saying that all you can do is put those 2 oxygens together, how are you going to put only 2 things together but share enough?
You're not.
You
You got to put it in the right way. Like, you got to, like, wiggle it. Yeah.
Okay. So what you're going to imagine is what I'm going to do, and it looks awkward here. So I'm actually going to end up sharing those 2 and those 2. 1, 2, 3, 4. So that This oxygen on the left gets to count all of those. 1, 2, 3, 4, 5, 6, 7, 8. And the oxygen on the right gets to count all of those. 1, 2, 3, 4, 5, 6, 7, 8. And this guy is written as, it's a double bond, right? This is O2. And this represents a double bond. I am not going to get too far into double and triple bonds other than having you know that they exist and know that oxygen likes to make them. That's really the only thing there. But one of the reasons that I wanted to do it this method where I'm literally turning and flipping the pieces is because the thing I am asking you to do this week will actually allow you to do that. Okay, so as I said in my email, this is our only class this week. I just wanted to be able to show you that skill. However, if you need help with anything, instead of having class on Friday, I am having an extended office hour period. I am not going to hang out on Zoom from 11 to 2 p.m. But if you send me a remind chat or an email saying, hey, can you meet with me really fast? I will go and log on and then I will meet with you. Otherwise, you again have a regular ed puzzle. I posted it yesterday. That's due on Monday. There is still no Calm this week. And unlike the last 2 weeks, there is not a Wiser assignment either. So what I am asking you to do instead is to play a game, all right? And you have to play a certain number of levels on this game to get full credit. So that's what I want to show you. So this is how you sign up for the game. This exact piece right here is on the weekly plan. So it's almost exactly like when you signed up for Ed Puzzle at the beginning of the year, like I showed something, it looks exactly like that. So you go to that website, you type in my class code, and I need you to use an actual name that I recognize to be able to give you credit. Once you sign up, you can actually play any of the games that are available in Collisions, but what I am asking you to play is the covalent bonding game because that's what we're doing. So there are a total of, I think, 15 possible levels of the covalent bonding game. You only have to complete levels 1 through 7 for full credit. And when I say full credit, I mean 10 out of 10. So this is an assessment. So it's actually pretty easy to get to that full 10 out of 10 credit with levels 1 through 7. Now, I will say some people might want to boost their assessment score. So I am providing an opportunity for you to do that. If you go on to levels beyond 7, you can get extra credit. If you play in the sandbox, which it will show you what that is, if you play in the sandbox, you can also earn extra credit. So I'm providing you with opportunities to be able to earn extra credit on this assessment assignment. Does that seem fair?
Yeah.
Wait, so is there
Can
no
you send the
Ed
link and remind?
Puzzle?
What?
Not Mr. Wells, is there no Ed Puzzle or like, is there an Ed Puzzle?
There is still an Ed
Yes.
Puzzle due Monday night, but you only have you basically have an Ed Puzzle every week and one other thing. So this is your one other thing this week is to play this game.
When is the game due?
What?
When is the game due?
Everything I'm going to stick with being due Monday night.
Okay.
Is there a class code? Because it says that you need a class code.
Yes,
Yeah.
it's on the screen. SPS VR 101.
Oh,
Miss
okay.
Jacqueline, can you send that in a remind?
Yeah, I will send that little image as well in the remind.
I gotta go. I have to go to AP World.
Yeah, no, I know. I'm pretty much done with class. So if anybody
All right.
has questions, you can hang on, but otherwise, yeah, class is essentially done.
Bye, Miss Baskin.
Okay,
Bye,
bye.
Miss Baskin.
Thank you.
Uh-huh.
Thank you.
Is all that?
All right, Miss Baskin.
I'm his basement.
Always going to be in the assignments page. So I'm clicking over to the assignments page.
All right, Miss Baskin.
The
Bye.
last couple of days, so
Is all that in the class plan thingy?
Yep.
All right. Peace out.
Bye.
Miss Baskin.
Yes.
So basically, for when when the electrons are being shared, you can only have them be like I don't know if this is gonna make sense. They can only be shared with like ones. Like, does that make like? Here.
Yes. Yeah. For the most part, absolutely. So for instance, let me switch back over. Yeah, so for any of this stuff, like carbon with these dots, it can share in all of those spots, but nitrogen with that, these, you can't bond there.
Okay.
Yeah, you can only bond where you've got singles.
So wait, why would they share instead of transferring?
Because typically when you put two elements together like this, that like for instance, if I had well let's look at the nitrogen and the fluorine, right? So nitrogen here with that and a fluorine, like how do you decide who gives and who receives?
Right.
Right?
Yeah.
Like, so because if you did that, well, sure, the fluorine's happy, but the nitrogen is not. Nitrogen would have to like give away how many? 5. Guess what? That's not going to happen. It's way.
Would it be able to, but that wouldn't be able to bond completely.
Right. So that's
Yeah.
what I'm saying. Like when we give and when we transfer electrons, we always have something that is receiving up to 8, and the other thing has to lose them all. Nitrogen is not going to lose all 5 electrons, right? Because these two are staying together.
So
that's
like when you're transferring, this isn't like when you're transferring where you can just make another
correct.
fluorine.
Yeah, that's why I said I will specifically tell you how many you are dealing with.
Ah, okay.
Yeah, so it's a little easier. So knowing that those two are going to make a bond, and then I would have another.
Okay.
Yeah. So, and then this guy would end up looking like nitrogen with 2 dots, fluorine, 1, 2, So, and in the collisions game that I'm having you play, like the same way I rotated the pieces, you get to rotate the pieces.
Oh, okay.
Yeah. So it's much easier to think about because you will do literally the exact same thing I did.
Is there like a correct way to rotate them?
No, but you'll see that essentially they only fit in one way. So you are going to be spinning and moving things together to where this like a single spot on fluorine and a single spot on nitrogen can line up, and then you can make them bond.
Okay.
Yep. All right. Covenant, Michaela, Rain, any of you guys got questions? Are you good?
I have a question.
Yes.
Is that possible to get higher than an A in your class?
Probably not. Besides the fact that, I mean, Aspen doesn't let you enter anything higher than an A anyway.
Oh, okay.
Sorry. Rain, Michaela, you guys good?
I have a question.
Yes, ma'am.
Just for like the collisions game, when is that due?
Monday night.
Okay.
Yeah, so I'm just gonna stick with the having things due Monday night because that's what we're used to, so that seems easiest.
Okay, and if we're having trouble with it, can we talk to you?
Absolutely, that's why I've got a 3-hour office hour period on Friday.
Okay. Thank you.
Okay.
Thank you so much, Ms. Baskin.
Okay.
Bye.
Bye.
Bye.